Hi everyone, my name is John Tabor and I'm here to help you review and know the materials for the CompTIA IT Fundamentals Plus FC0-U61 exam. I am going to be going through the material based on the all-in-one exam guide presented by TotalSeminars. This textbook was written by Scott Jernigan and Mike Myers. And this is the second edition, or for the second version of U61. There was a U51 version out there, and that has now since expired, so we are now on the next version, which is U61. And there are some major changes that happen between the U51 and U61 that we will be covering. I will be going through a chapter-by-chapter guide to help you understand all the different objectives that you should know. At the end of every chapter, we will then go over a anywhere from 10 to 15 question review over what we covered and how you did. So you're welcome to pause the video at any time, review at your own leisure of what you need to know. The CompTIA IT Fundamentals exam is only one exam. Some other CompTIA tests, such as the A+, is actually broken up into two parts. The CompTIA IT Fundamentals Plus exam is only one exam. It is 75 questions. It is a timed exam, and you would only have 60 minutes to answer these questions. All of them are multiple choice. There are some where you do need to mark more than one answer, but for the most part, you just have to choose one by clicking on it. The exam is based out of 900 points. You do need a 650 score or better to pass. And unlike the U51 exam, the U61 exam is broken up into 6 domains. The six domains are broken down here on this slide. The first domain is IT concepts and terminology for 17% of the examination. That's about one out of every 6 questions. Infrastructure is 22%. If you look down the list, that is the largest portion of the exam. Applications and software, 18%. Software development, 12%. Database fundamentals, 11%, and security is 20%. What we will be going through will have 4 main parts. We are going to go through a chapter-by-chapter video series to help you as we do this, but there are 4 main parts for this exam guide. Part 1 is the computer basics for chapters 1 through 4. Part 2 are setting up and using computers, chapters 5 through 9. Networking, security, and maintenance is part 3, chapters 10 through 13. And databases and software development are actually the brand new material introduced in the version U61, and that is the last 2 chapters that we will be covering, chapters 14 and 15. So we're going to start with part 1, the computer basics, and as I mentioned, it covers chapters 1 through 4. Today we'll be talking about chapter 1, is how people use computers. Eventually we'll go through chapter 2, 3, and 4, in those information down below. So on chapter 1, how people use computers. Now before we start, I need you to understand that just like when you go to a restaurant, if you're not sure what they have to offer, you might end up ordering some sort of sampler plate. It's a little bit of everything that they have. And that's kind of what chapter 1 is about. It kind of covers a lot of everything that you need to know wrapped up in this first chapter. So there's going to be a lot of different, very diverse information presented to you. Just keep in mind that we will go through each one of these specifically in more detail in future chapters. So do it as best you can as we go through this. And again, this is just the basics. We will dive down a little bit deeper with each concept as we get started. So the first thing you need to understand is, what is a computer? Now most people are more familiar with the word computer being like a desktop computer, even a laptop computer. Most people also understand that a smartphone is also basically a mobile computer. You also have tablets and other things that can be portable. But realize that computers are found pretty much anywhere now. They're found in grocery stores, in checkout lines, they're found in businesses and factories, they're found in offices and schools, they're found in churches and transportation stations, they're found everywhere. And technology is pretty much running the show in the world nowadays. And so computers are anything that has some common devices, or I'm sorry, some common features to it, and we're going to be talking about those common features of what makes a computer and what helps you to understand what those are. What can you do with computing devices? Again, you can do a lot of things with it. You can communicate with it using either voice or face-to-face interaction. You can share things with colleagues. You can learn by searching the internet. You can create things and build things. There's a lot of different things that you can do with computer devices. So some features that are common to computer devices. The first thing I want to talk about is this newest thing called Internet of Things. Now, you might not have heard it called this before. It's also abbreviated as IoT. But the Internet of Things is a specialized computer device that can communicate data over the internet that does not include computers and phones. So some examples of that are such as like smart cars or security cameras. There's even some home appliances. You can hook up a washing machine or your refrigerator to the internet. Your refrigerator, for example, will take an inventory of what's in it and then give you the shopping list based on what you don't have anymore. It's pretty remarkable, but this is starting to become more and more prevalent in homes, these Internet of Things. It's basically just household devices that are now connected to the internet that help you to be able to be more efficient and more convenient for you. Also, another feature common to computing devices is a processor. A processor is a super fast electronic calculator that can either carry out, or a computer term, execute computations based on the programming. So somebody has to go in there and program it, and then the processor will do those operations for you. And that leads us to the next one, which is called programming. Programming, again, computers wouldn't know what to do if there wasn't somebody out there, a programmer, to tell it what to do. So programming are the instructions of what the programmer wants the computer to do. Now, this can usually come in two forms. You can come in the operating system, and that's how users can interact with the computer, as well as the applications, programs that enable the computer to accomplish specific tasks. Next is data storage. Data storage, again, most computers can hold a certain amount of data. Computers that we use most days have a large amount of data to store. Some of the things don't need very much data in order to operate and run smoothly. But data storage are where, I don't know if you're familiar with this, but when we had the earlier computers, and we're talking about in the 50s and the 60s and the 70s, they used to have these huge computers that filled entire rooms, and they had punch cards. And these punch cards stored the data and for you to be able to do what you needed to do. Now, data can be stored internally within the system memory, or even externally with hard drives or disks or flash drives. The ways that we can store data now have gotten much quicker and are more compact and more mobile and easier to use. Data assets are values assigned to a computer information by individuals or organizations. You have two main data assets. You have data and information. And don't get those two confused. Data is the raw numbers. You put all the raw numbers, you put all the data into the computer will then process that data and it becomes information for you. So data is the raw numbers that get put into the computer, and information is the things that comes out of the computer to help you understand it a little bit better, that raw data. As we mentioned already, we also have some hardware devices, some things that actually physically go into the computer, such as the memory, such as the RAM, such as the chip or the CPU. We're going to talk about a lot of these different things later on in another chapter. Your operating systems are part of the computer to help you interact with it better. You have your applications or apps, as we mentioned before, and your output interaction options, the ways that we can get information out of our computer. Some common general purpose computing devices. There's this thing called a multi-user computer. Now, when I think of a multi-user computer, and you can see a picture of it here on this slideshow, I also think about like Star Trek. If you're familiar with Star Trek, you've got the captain's chair, and then back behind the captain's chair, you've got this whole wall where people are lined up doing their own things. I imagine that as a multi-user computer. It's one giant computer where there's different stations. You've got the shields stations. You've got the the engine stations. You've got the different parts that makes the ship run, such as the weapons station and the security station and all these different things. And each person has their own specific spot on this computer. So more than one person can use this computer at the same time. And that is considered a multi-user computer. Examples of that are mainframes, mini computers, supercomputers. Mainframes are large multitask machines. Mini computers are just the same thing, except they're smaller multitask machines. And then supercomputers are large machines focused on one single task. An example of a supercomputer is actually coming up. This is the year 2020 at this time of recording, and a census is getting ready to happen. And you're going to have a supercomputer. It's a huge, large machine that's going to be intaking all of the data that people around the country are submitting to it. And it has to be a supercomputer because a regular computer would not be able to handle as much information as being sent to it. So a supercomputer would be like tallying census results, geothermal imaging data. There's a whole bunch of different things, but it's always focused on one single task. You can, as I mentioned down below, it's used for massive number crunching. So the tallying census, the geothermal data, even CGI movie effects. In the movies Lord of the Rings, the very first Lord of the Rings movie that came out, they did a lot of special movie effects, and it took hours and hours and even days sometimes for it to handle and compute and process everything that it did. By the time the last Lord of the Rings movies came out, actually even the Hobbit movies, when those came out, they used the exact same, they tried to do the exact same movie effects, and with the new technology that they did, it took minutes instead of days. So it's pretty amazing, but it can handle more and more data as we go through. Other than multi-use computer, you also have dedicated computers. Dedicated computers are things such as what we're familiar with: desktops, what you can see pictured here, or laptops, things that you can carry around. They can either be standalone or they can be linked together in some sort of network. All right, so as I mentioned before, you have operating systems that are part of a desktop or a laptop system, and we will abbreviate that as OS. OSs form basis for user interaction. They're the way that we as a user can communicate to this computer. And you can do it a couple different ways. You can either do it using GUI or command line. Now, before I get into that, I want you to understand what OS is for a minute. OSs are pretty much divided right now into two main types. You have Windows OS, which is Microsoft, and you have Apple OS, which is from the Apple company. Those are two different operating systems for two different types of computers. Now, there's other ones out there as well, but those are the two main ones that dominate the market right now. And these OSs enable applications to work, and these are designed to run on a specific hardware platform. If you have a Windows computer, it's designed to work on either an IBM platform or an Intel platform. If you have an Apple computer, it's designed to work on a Macintosh platform. Those two can't be interchanged. You can't take a Windows computer and then install an Apple onto that. Now, there's ways to work around that, but right now, those are two distinct, exclusive operating systems. Now, as I mentioned before, you can interact with a computer two different ways. You can use a GUI or a command line. Now, GUI stands for Graphic User Interface, and it displays a picture on a monitor, and the user interacts with it using a mouse. It's basically what we're familiar with when you log into a computer. You see icons, you see buttons, and you can click and point and do this and do that, and it's a way for you to easily interact with it. And most people, the general population, loves it, and that's exactly why it was created, to make it be user-friendly. Now, there's other ways for kind of the more hardcore computer users called command line, and you can see this over on the side. These are a command prompt for a couple different ones. The top one is for a Microsoft Windows command line, and then the bottom one is actually an Ubuntu Linux command line. It's another type of computer system that we'll talk about later. But again, most people are using the GUI, which is point click on pictures, but some people like the command line where they type in the commands. They say run this or stop that, or the different things that you can possibly do. Now let's talk about the different operating systems. Now the first one we already mentioned, you have Microsoft Windows. Now one of the earlier versions was Windows 7. That's actually still around. However, it's currently not being supported anymore by Microsoft. But a lot of people, myself included, love Windows 7. It's very user-friendly, and there was not a lot of things that people didn't like about it. Windows then created Windows 8. And Windows 8, and we're going to get into this a little bit later when we talk about operating systems, wasn't a big success. And so that a lot of people liked the new features, but they liked the old features. So they ended up making Windows, upgraded it to Windows 8.1, which is more of a hybrid between Windows 7 and Windows 8. And the newest operating system right now with Windows, excuse me, is Windows 10. Another type is Apple MacOS. Now, MacOS is, again, for Apple computers. It can do the same as Windows, but it can actually do a lot more if you're into music or video or graphic arts. But the Mac OS is the operating system for an Apple computer. And these are the different versions out there right now. The newest one is Mac OS. Another type, which a lot of people don't know about, except again, a lot of hardcore computer people out there, is called Linux. Linux is an open source operating system. Now, the first two that we just talked about, Microsoft Windows and Apple Mac OS, are closed source. What that means is that you can't go in and change the code. You have to use the operating system as it's presented to you. Now, there's a lot of things you can customize, but you can't go in and do any kind of variation to it. Linux is an operating system that's open source. So it allows more flexibility for users to modify or adapt the system to do what they want to do. There's a lot of different variations out there, which we call distros, short for distributions. And distros, the most popular one is, as I mentioned in the last slide, it's Ubuntu Linux. And Ubuntu Linux is completely free. You can go online, you can Google it, you can find a version of Ubuntu Linux, and you can download it and you can use it, and it does not cost. You cannot do that for Microsoft Windows, you cannot do that for Mac OS. Those versions cost money. But again, Linux is completely free, and it's free to download and free to use. So we've talked about Windows, we've talked about Mac OS, we've talked about Linux, and again, we're going to go into all these in more detail in later chapters. And the fourth one is Chrome OS. Now, Chrome was created by Google. Google did not have an operating system on the market, and they saw Microsoft and Apple dominating the market, and they decided they wanted to get on the game as well. So they created Chromebooks, and they created Chrome computers dealing with an operating system called Chrome OS. This is actually a variant of Linux. It's designed by Google for thin clients. Now, thin clients has nothing to do with the size of the people that are using it, so stop it. Thin clients are minimal computers designed for internet only. So if you have a Chromebook and you do not have an internet connection, you're going to be very limited with what you're able to do, because there's actually very little storage on a Chrome OS device. Most of the storage that you use for a Chrome OS is based on the cloud, where you save things to your Google Drive, or you save things to a Dropbox, or to OneDrive, or something in the Google Cloud that has to be internet connected. So again, Chrome OS is great, but it's designed for thin clients, which again are minimal computers designed for internet only. They do lack the ability to run a lot of applications unless they are internet connected. The next thing I want to talk about is mobile computing devices. Now, mobile computing devices can be broken down really into three different types. You have smartphones, you have tablets, and you have other specialty devices. And we're going to talk about all of these. Now, smartphones are tiny computers that can use the internet on the go. It's a mobile device, keeps you organized, and you can access data away from your PC. The most common smartphones out there are iPhones, Androids, and Windows phones. Now, iPhones and Androids, again, dominate the market. They take up the majority of the market, and we're talking about in the high 90%. Windows Phone used to be a big thing, but a lot of people didn't get on board with it, so it's kind of obsolete now. Blackberries, again, there's a select crowd of people that still use Blackberries, but there's not very many out there anymore, so those are mostly obsolete. Now, smartphones have their own operating system. We're going to get into that later, but that is one type of computing device that's a mobile computing device. Tablets are a digital slate with a touchscreen. You can see a tablet over there in the picture. They look like a large smartphone, but most of them you cannot call or text people on it. There are some smartphones where you can call or text like a normal phone. Those are actually called phablets. P-H-A-B-L-E-T. It's a phone tablet, a phablet. Not as popular as regular phones, not as popular as regular tablets, but there are some out there that you can combine them together. These tablets are more powerful than a smartphone. You can do a lot more with them, especially with normal computer usage. The most popular tablet out there is an iPad, but there's a lot of other ones out there as well. And then finally, you have specialty mobile devices. These are devices that are more popular for a specific task. They really are created for one reason. A tablet and a smartphone, there is so much that you can do with these. They're just very diverse. But a specialty device is popular for a specific task, such as reading or calculating or a map or something like that. Some examples of that are like the Amazon Kindle. Kindles are great for reading. And really, that's the main purpose of it. You have a scientific calculator or a graphing calculator. Those are mobile computing devices that their main purpose is to calculate and to do things based on, a mathematics or some sort of equation. And then you have GPS units, which would be specialized for maps to help you get from point A to point B. Again, these are specialized devices. They are mobile computing devices, but they have one purpose. Now, with mobile computing devices specifically for smartphones, as I mentioned, there are actually, there are actually 4 different operating systems, and you can see that underneath where it says smartphone. You have your Apple iOS. This is a common OS found on iPads and iPhones. It's similar to the functionality of Apple PCs, and you usually cannot find iOS on an Android phone. Those are two different things. Androids are a common OS found on Android phones or Android tablets. It is a variant of Linux, and Androids, again, are out there. If it's not an iPhone, it's an Android phone, whether it's a Samsung, whether it's a Kyocera, whether it's a Motorola. If it's not an Apple iPhone, it is an Android phone. And then you have the other ones that are not as common. There are still a few of these out there, but they're not as common as the others of Windows Phone. It's a mobile device version of Windows. It was not widely accepted as Apple or Android. And you have your BlackBerry. It's a proprietary OS used only on BlackBerry smartphones. Once it was very, very popular, but it's slowly becoming extinct. One of the things that are very, very important about BlackBerries, and it's a distinct feature about BlackBerries, is that it had a hardware keyboard. Most iPhones and most Androids have a virtual keyboard where the keyboard pops up on the screen and you type using that. A BlackBerry was known as a distinct feature of having a hardware keyboard. You had these tactile buttons that you pressed as part of a slide out feature or as part of the bottom of the BlackBerry phone anyway. The next thing I want to talk about is networks. Networks, there's some terminology about networks that I want to go over. We'll talk about the picture over there on the side here in a minute, but it's very important to understand some important things about network. Now, the word network in terms of IT fundamentals stands for two or more computers communicating. So when someone first created a computer and someone else had another computer, they thought, hey, I would love to share my files or my system code or my programming with you. And they had to take either like a big disk or a big some sort of take the hard drive out and move it over to the other hard drive, or the memory out and move it to the other memory, the hard drive, something like that. And they decided to hook up these two computers and make a network. And they used a cable, and then they were able to transfer information from one computer to the next using that. Now that is basically the definition of a network. Now you have two types of networks. You have a LAN and a WAN. A LAN is a local area network. Local area network, it connects computers to a single location, such as a school or an office or a home. And you have to have some equipment to be able to do this, but it's an easy way. Most people in their home right now have a local area network. You can communicate. I can send my files to my wife's files, to my wife's computer through this LAN here. So a LAN is just basically two computers in the same location that are sharing information. Now those two computers do have to be connected, but through either wired or wirelessly, but that is a local area network. Now a wide area network basically takes a LAN and another LAN and connects them together. So I would take a computer in my house, I would take a computer at a local school, and then I could share files back and forth with them. And so that's a wide area network. So just know that a local area network is within one location, and a wide area network connects two locations. In order for you to have, didn't mean to go forward. In order for you to connect two computers, you need to have something called a switch. Now, it is a box that physically connects computers using cables or cords. And there's a lot of different switches out there. Most people have a router in their home. If you look on the back of your router, you will see some ports for where you can plug in a cord, an internet cord. And then that cord allows you to share my information through the router to someone else. That router is actually a switch, and the switch allows me to share information within the LAN. Back to the word router. A router is a box that allows a computer to communicate with other networks beyond their current one. If you want your LAN to connect to another person's LAN, you need a router. And you can send that data through a phone line, you could send it through a DSL connection, you can send it through cable television lines, you can send it through network cables. There's a lot of different ways to do it, and some are faster and better than others, but you can send that through a router. So if you want to get out of your LAN, you need a router to get you out. So if you look at this picture down here, we actually have three different LANs. You have this LAN up here on the top, you have this LAN over here, and you have this big LAN down here on the bottom. Now, in order for these LANs to communicate with each other, let's back up. In order for each computer in a LAN to communicate with each other, they just need this blue switch box. This one can send information to this one. This one can send information to this one. That's great, that's easy. But if one of these computers wants to send it out to another computer, they need to have that switch box hooked up to a router. Once they get hooked up to a router, that router will send the information to another LAN, vice versa. So it's important to make sure you understand, to connect within a LAN, you need a switch. To connect out of your LAN, to get to another LAN, I need a router. Now you are allowed to connect wirelessly, and you would need some sort of wireless access point where computers can connect wirelessly. Now again, in most people's homes, you have a router set up next to a TV, next to your computer, and that allows you to be able to connect to the internet. Well, more importantly than that, That router is a switch. It allows you to connect with one another. It's a router. It allows you to connect outside of your home to somebody else. It's also a WAP, which is a wireless access point. It's where you can connect to it wirelessly. Your phone can be hooked up to your Wi-Fi, which is through your router. So it serves as a multi thing. Servers and clients. Remember that servers are machines that fulfill specific roles on a computer network. You can have a file server. It takes care of any files that you create or download or delete. It can have an app server, a mail server, which takes care of any outgoing or incoming mail, a print server. If you print to a local printer, it will take care of all those different print jobs. Keep in line, but that's a server. And a PC that receives these services from the server is called a client. So a client is your individual computer. A server is what you connect to do different things with your client, whether it's mail or printing or doing things with files. And then finally, resource sharing is the capability to allow you to share resources instead of having multiples. You can connect, for an example of that, if at a school, if there was 15 or 20 computers in a classroom, instead of each one of those computers having their own printer, you can connect all of those printers, you can connect all of those computers to one printer. A remotely accessed computer systems. There's some important things on this, where it's where the clients access the server. The server does not have to be on site. The server could be in a different building, in a different LAN, in a different city, in a different state, even in a different country, a different part of the world. You can remotely access a computer system. Most everything that we do online, whether it be Google Drive or whether it be connecting to an app that's not stored on our phone or stored on our computer, that is using a remote access computer system. You can do it using mobile apps. These are obtained from online stores that protect users by ensuring the app is safe and virus-free. Most are server connected, but some can be standalone. When you download a new app to your phone, you are connecting to an online store, and it protects the users because it will make sure that you're downloading something that's safe. Streaming media is media that has to be connected to a server in order to access it. Popular streaming sites are Pandora, Spotify, even like movies like Hulu and Netflix, anything like that where you're streaming media. It's not something that you downloaded to your computer, but something that's just constantly coming into your computer from a remote accessed computer system. Web apps are apps that are directly connected to a server to use and access. You can usually access these with a browser, such as Google Drive or MS Office Online, which is what you see over here on this picture. They do require the internet. Cloud computing are apps and data that you can access online rather than on a PC. It sometimes has a subscription and can be cheaper than buying a full version. And whenever you do this, the nice thing is that updates are automatic and free rather than pay for upgrade. So when we talk about the MS Office Online, you usually have to have some sort of subscription to that. You don't have to keep upgrading your Office software because your subscription pays for that. But it's accessing resources hosted online. It does have a subscription sometimes, and there's less need for things that you need to download locally. Virtualization is very important. What virtualization is it's a running a system inside of another system. So let's say you have a Windows computer and you want to go to Linux. Well, you can use virtualization software. You don't have to buy a brand new computer for Linux. You don't have to buy a brand new computer for Apple or iOS. You can, Mac OS. You can run one of these other operating systems inside of your current system using this thing called virtualization software. It is a virtual machine, and it's a lot of times it's extensively used in networking. It does run on an OS. It might be different from the PC's OS, and this thing can save companies money on hardware purchases, repair, and maintenance. Now there's two types of virtualization software. These are called hypervisors. And there's a type 1 and a type 2. Now a type 1 hypervisor does not require an OS. It's designed to share hardware resources among virtual computers. It can be more efficient and more stable than type 2. A type 2 hypervisor does require an existing OS, and you run it as an application software. There's a lot of unrelated stuff running, which does slow down the system. So the type 1 is always the better one, and the type 2 can be fine, but it can also slow down your system. So type 1 does not require an OS, but type 2 does require an OS. All right, our last slide that we're going to deal with today is specialized computer systems. Now, we talked about specialized computer systems in our earlier slide. We said that their job is to do one specific task, not like a phone, not like a tablet. It has one job. The first one is called a point of sale terminal, also sometimes called as POS. What a point of sale terminal does is it processes purchase transactions. You can see in this picture over here, this is a credit card reader on a gas pump. That is a specialized computer system of a point of sale. Its one job is to take your credit card, read it, scan it, accept it, and it will take money out of your account in exchange for the gasoline that you buy. They contain input, memory, and minimal processing power. They have to take information into it, they process it, and then they remember what they processed. But it's very minimal because it doesn't take a lot of information or a lot of computing power to do what it needs to do. The next thing is called an ATM. If you didn't know, an ATM stands for an automated teller machine. And that is a specialized computer system because it's designed for banking purposes. It uses something called multi-factor authentication. What that means is that whenever you use an ATM, you don't just have to prove who you are once. You have to prove who you are multiple times. And one is typically through the credit card that you hold or that you have. The other one is through something that you know. So something that you possess, the credit card, and something that you know, the password. If you know both of those, that's a multi-factor authentication because anybody could steal your credit card and then you empty their bank account and that was it. But if someone steals your credit card, it's basically like a fail-safe to make sure that the person knows what the password is as well. GPS is Global Positioning Satellite. These are outdated devices that locate your position based on satellites. Every location on Earth, wherever you are on Earth, if you have a GPS unit with you, you have access to at least 4 satellites. Based on the speed of light, it can determine where you are within a few feet. So it's pretty remarkable, a GPS global positioning satellite. But again, it's a specialized computer system. It's got one job, which is to figure out where you are, or as a GPS, unit, it can help you go where you want to go. VoIP stands for Voice over IP. IP is Internet Protocol, Voice over Internet Protocol. It uses the Internet for phone calls. So instead of picking up the phone and dialing a number, you can have a conversation over the Internet instead of over the phone lines. Some examples of that are Vonage or Skype, or FaceTime. A lot of those would also be using your voice. Better quality, cheaper, and has additional features than landline. Now, a couple types of things about VoIP is you have telepresence and teleconferencing. Telepresence is a high-quality video equipment to enable the user to feel almost present at the meeting. Sometimes it's virtual reality. So they actually have like a computer on a chair, like where you would normally be. You've got the computer, you got the camera turned on. You can see everybody. They can see you. It almost looks like a person with a camera or with a computer face. And it makes you feel like you're actually there and you're having the conversation where it is. So your presence, you feel the presence of the meeting, and it's called telepresence. Teleconferencing is video-enabled remote meeting. It uses a microphone and a camera. In order for you to have any kind of virtual conversation with somebody, you need to make sure that you have a camera to see, a microphone to talk, and an internet connection to be able to connect to wherever you're going. The last thing I want to talk about, which is just kind of thrown in here, is POTS, and this stands for Plain Old Telephone System. So instead of talking over an IP or over the internet, you talk through a phone line. And yes, it's called POTS, Plain Old Telephone System. And you talk via a telephone line. A telephone line, and the actual name of the cord is an RJ11. The name of an internet cord is an RJ45. We're going to go through all these cords later on in a different chapter, but instead of using internet to talk, you're using a plain old telephone system, POTS. So that's it for our slides for the information from chapter 1. There's, like I said, this is kind of a sampler. It's a lot of everything, but very shallow. We're going to go deeper into every single one of those in a chapter by chapter basis later on. So I've got some review questions that you are welcome to look at. We'll go through together. You can pause the video and figure out what your answer would be before we go over it together and see how you did. Okay, this is from chapter 1 review questions. Number 1, which factor distinguishes IoT devices from standard computing devices such as laptops or smartphones? Feel free to pause the video if you want to try this out. A, they must run as virtual machines on a Type 1 hypervisor. B, they are specialized devices. C, they must run as virtual machines on a Type 2 hypervisor. D, they are kept isolated from the internet. The answer is B. They are specialized devices. IoT devices only really have one job, and that is to, if it's your heating system connected to the internet, you can connect to it with your phone and determine and change the heating system. If your washing machine is connected to the internet, you can change the settings on the washing machine and run the washing machine, but again, it just has one job, whatever it's connected to. So it's a specialized device. Number 2, how are information and data different? A, data is processed information. B, information is processed data. C, data does not need to be backed up. D, information does not need to be backed up. The answer is B. Information is processed data. Data is the raw numbers. Information is what you get from the data after it's processed. Number 3, what type of computer, also called a notebook, has a monitor that folds down to cover the keyboard for transport? A, server. B, laptop. C, GPS. D, mainframe. The answer is B, laptop. You can shut it like a notebook and it folds down. Number 4, what would be an appropriate use for a supercomputer? A, playing online games. B, running a high-volume website. C, tallying census results. D, managing a large business's accounting department. Remember, a supercomputer is a large computer that can handle one job. And the answer is C, tallying census results. Number 5, which of these is a workstation operating system? A, iOS. B, Windows Phone. C, Windows. D, Android. All of these are operating systems, but only one is from a workstation. A workstation is not a mobile device, and so iOS is your mobile device, Windows Phone is a mobile device, Android's a mobile device, C, Windows is our answer. 6, which of these operating systems cannot run on a desktop PC with an Intel processor? A, Linux. B, iOS. C, Google Chrome OS. D, Windows. An Intel processor deals with a Windows phone. So the only one that cannot go with a Windows device or a Microsoft device is your iOS, because that is a mobile device, not a desktop PC. 7, what kind of OS enables users to interact with it using a pointer and graphics? A, command line, B, GUI, C, decentralized, D, centralized. Pointer and graphics is that graphics user interface. This is B, GUI. Number 8, a version of Linux packaged with add-ons and utilities for a particular purpose is known as A, distro, B, GUI, C, version, D, service pack. A version of Linux is known as a distro. Number 9, a BlackBerry is a type of smartphone known for what distinctive feature that most other modern smartphones lack? A, graphical screen, B, internet connectivity, C, touchscreen, D, hardware keyboard. Remember, a blackboard is always known for that hardware keyboard, that tactile touch buttons. Number 10, what operating system is used on an iPad? A, macOS, B, Windows, C, Android, D, iOS. Don't get these two confused. We know it's an Apple device, and both macOS and iOS are Apple operating systems, but one is for a desktop or a laptop, while the other one is for a mobile device. An iPad is a mobile device. The answer is D, iOS. 11, what kind of network is used to connect individual computers in a single physical location? A, WAN, B, LAN, C, internet, D, remote. Single location would be a LAN. WAN is where you want to get out of your location and connect with somebody else, such as the internet. Number 12, listening to music listening to music using an online service like Spotify is an example of what? A, cloud computing, B, virtualization, C, streaming media, D, telepresence. Spotify is an example of streaming media, C. And finally, the last question, number 13, you are running virtual machines on a single physical server. The server operating system does not run any other applications and is dedicated to virtualization. What type of hypervisor is this? It is dedicated to virtualization, and the operating system does have a part to it. The answer is A, type 1. All right, thank you for following along. We were able to go through everything that I wanted to today regarding our CompTIA IT Fundamentals All-in-One Exam Guide for Chapter 1. Feel free to join us for the next video for Chapter 2. Comment down below if you have any questions. I'll try to respond as best I can. And as always, keep on keeping on. Thanks. Have a great day.